Welcome back, my lovely students, to part 2, proper and improper fractions. So a fraction whose numerator is less than the denominator is called a proper fraction. A proper fraction has an absolute value between 0 and 1. Oh, look, more things we haven't discussed yet. Absolute value is a fancy way of saying the number's distance from 0, or you can kind of think of it as the number's measure, like on a ruler, if you started at the beginning of the ruler. So here, saying the absolute value of it is between 0 and 1 means that it makes up a fraction of one whole and only one whole. So it doesn't go bigger than one whole, and it doesn't go smaller than a negative one whole. That's why it says absolute value, because negative fractions are kind of weird to think of in the part whole sense. So what that means when we look at the fraction is, if it's between 1, it means I don't make a whole. Then a fraction whose numerator is greater than or equal to its denominator is called an improper fraction. An improper fraction has an absolute value greater than or equal to 1. So back in like elementary school, once you learned about this mixed numeral thing, the teacher would harp and harp and harp about you need to write the mixed numeral. We don't write improper fractions anymore. When you get to college, unless you're answering a word problem, we turn that back over and say, no, leave it as the improper. I don't want to think about the mixed. And it's because we can't tell which way you guys are writing sometimes. Like 43/25, the way this is typed, I can clearly see that is what is meant. But if I type it this way, still looks like 43/25. But what if I wanted to say 4 and 3/25? How would I type that? And generally it is, we put an extra space in there, but that is way too subtle. And with handwriting, it's really hard to tell. So this is why math teachers after a while are like, no, go back to improper. I don't want to deal with mixed, because it's less vague for us. We'll just always assume it's an improper and assume that's 43/25. So I'm just letting y'all know, like, we have this whole proper improper debate. Really, it's just write whichever answer makes sense. If the mixed numeral makes sense to you, especially in the context of the problem, write that. I will figure it out based on the work you're doing and give you the benefit of the doubt. So label them as proper or improper. So 8/31. Are there fewer copies than there are number of parts? Yes, only 8 copies, but the number of pieces is 31, so this guy is proper. Then 19/9. Well, 19 is definitely bigger than 9. So I've got more than 9 copies, or 9 copies even would still count as improper. So this is improper. 43/25. Yep, that's bigger than 25 on top. So that would be a whole and some leftovers. So this is also improper. And if you guys want to shorten when you have to answer something like this, if you're turning it into me, like, just IMP would be fine. Then D, 33/34. I can fit that in one pizza box. I haven't gone over 34 slices. So this is considered proper. All right. So we've talked about the fancy words, and now we'll probably ignore them for the rest of class. I'm not even really sure why they're in there. It might be that there's a homework question that asks you for this, but it's probably only once. Now, the moving back and forth between mixed numbers can happen more, so we are going to talk about that. All right. Improper fractions can be represented as mixed numbers. A mixed number is a sum of a whole number and a fractional part of a whole. A negative mixed number implies that both the whole part and the fraction are negative. In this sense, I like to think of I'm counting like on a number line. So I count my number of wholes in the positive direction and then the fraction part of the next one for the fraction. If I'm doing it negative, I count negative wholes and then the fraction of that next one in the negative direction. So there is a conceptual, what does this mean or where would it be on the number line? That's actually what you're doing on the number line is you're measuring it out. Okay. So we have a lovely little multi-step process for how to change the mixed number to an improper fraction. There's another way. You type 2 plus 3 over 5 and hit enter, and the calculator will more than likely give you the improper fraction, especially if it reduces. And on a lot of calculators, there's a button where you can actually tell it to go back to the mixed. It's just that can look a little weird display-wise. But here I have 2 wholes, but I want to know how many copies of fifths do I have? So in 2 wholes, how many 1/5 shaped pieces do I have? So in 1 whole, I got 5 pieces. In the second whole, I have 5 pieces. So that is each whole is 5 whole pieces to make up that 1 whole. So I take the size of my pieces multiplied by the number of wholes I have, and I'm just counting them. This 5 and another 5, so 2 5s is 10. And then I add my extra fractional part because there's this extra 1, 2, 3. So 10 plus 3, 13 fifths. So I'm trying to give you guys meaning behind why the process works. Like a way to think of it conceptually, because I find that gives you something to kind of bite your teeth into, for lack of a better word, something to get a good hold on. And hopefully it sticks better. Because just memorizing blind steps, when you run against a problem that's just a tiny bit different, the steps don't work right, but you can still blindly apply them and end up somewhere else that doesn't make sense. If you understand why the steps do what they do, then you can apply the steps more thoughtfully. A lot of elementary, middle, and high school teachers don't have the time for everybody to learn why the steps work because of the way they are pushed to get everybody ready for standardized tests and their job is on the line for it. Like we really screw over our public school teachers so badly. So I know some of you guys had bad teachers, and I'm not saying like, go back and tell them you forgive them, but just think about how much you hated that test. And now think about whatever job you might have or work in the future being dependent on how somebody else did on that test. It is way too much stress. All right. So now we have a negative. Meh, don't care. It just means I have a negative in front of my answer. 1 whole and 7 twelfths. Well, I know that 1 whole is 12 twelfths. So I have 12 twelfths and another 7 twelfths. 12 plus 7 is 19 twelfths. Now, if we were going to punch that on the calculator, we would do the negative of 1 plus 7 twelfths. If you do 1 minus 7 twelfths or negative 1 plus 7 twelfths without the parentheses, it's going to mess it up. So just know that since you had a whole, whether it's positive or negative, your result should be improper. The top should be bigger than the bottom. Now 9 and 14 over 17. So 9 and 14 17ths. That's just ugly. So 9 wholes, each of which have 17 pieces. So I have 9 groups of 17, which is 17 times 9. Y'all got a calculator. I would make use of it. 9 times 7, 63. So the 3 goes down here, the 6 goes up here. If you ever find yourself flipping the numerals, like you say 63, but you write the 6 on the bottom and the 3 up top, that actually has a name. It's dysnumeria or dysgraphia or dyscalculia. They use a bunch of different ones, but it's math dyslexia. And you can have it without letter dyslexia. And it is very hard for teachers to diagnose. So if you notice that, like, it's not a surprise you made it to college and no one ever said it. I'm putting it out there because you guys are old enough to realize that's what's going on, and you can get it diagnosed and get extra time on math tests. All right, so we put the 3 down here, the 6 up here. 9 times 1 is 9, plus 6 is 15. So that is 153 parts in the holes, plus the extra 14. So that's 7, 6, 1. So 167 17ths. And because the original would not reduce, I know this would not reduce. So that is the way this craziness works, why it works. We're talking about groups of the individual pieces. And I find it can even help to kind of think, all right, I've got 2 holes, but I want to know how many fifths are in there. So think about, taking a pie, you cut it into 5 pieces. You take the next pie, you cut it into 5 pieces. And then you got 3 more pieces left over because some jerk came and ate 2 of your pieces of pie. So there are 13 pieces left. All right. Now going the other way around is a little more awkward, but I have, 1/4 sized slices of cake, and I got 23 of those slices. How many whole cakes do I have, and how much of the last cake do I have? So perhaps I had originally sliced whole cakes, and I portioned out all these pieces, and now I count, and there's 23 of them. My brain is going, I think somebody ate a piece of cake, and I'm going to get mad. So to figure that out, one of the ways to do it, and this is what an elementary kid would likely do, is they'd start taking groups of 4 out of 23 until what they had left wasn't enough for a group of 4. That's the same thing we're going to do. And the fancy way is to magically know, because you know bone deep, that 20 is a multiple of 4, and it is in fact 5 4s. So there are 5 whole groups of 4 I can pull out of 23. You can also just take -4, that's 1, -4, that's 1, -4, that's 1. It's a little tedious, but that is what you're doing. So another way is if you type that division into the calculator, so the 23 over 4 or divided by 4 is going to tell you 5.75. Now I kind of ignore the fractional part because sometimes it's really ugly, but the 5 is the number of holes. So you can kind of ninja get your way to the first part of the answer on these by using your calculator. Use your tools. All right, so there are 5 holes, so I'm going to subtract off or group 5 groups of 4. So 5 groups of 4 is 20 pieces. And if I take that 20 off of the 23, there are 3 remaining. So I would say the 5 groups of 4 is 5 holes because 4 pieces makes a whole. So 5 holes and 3/4 left over. Again, there is a way to get the calculator to do this for you as well. But that is how we would convert that one back to a mixed number if we were doing it by hand, and the meaning behind that. So I had 5 whole cakes, yes, and 3/4 of a cake. Somebody ate a piece of cake. All right, -41 fifths. That's a lot in the negative direction. Perhaps I served the cake at a wedding. They were all 1/5 sized slices, and I want to know how many whole cakes actually got eaten so I can bill correctly. So I got 41 dirty plates, 41 negative pieces of cake. So we want to figure out how many groups of 5 can I get out of 41. And if you're comfier with your numbers, you can kind of figure out your 5 times, 6 is 30, 7 is 35, so 5 times 8 is 40. It's one way to go about it. You can just start pulling 5s or 10s even off of the 4. There's 4 groups of 10 in 41, and 10s are 2 5s, so that's 8 5s. Or again, you can just crunch it on the calculator and take the number up front. It'll say 8 point something. So that is 8 groups of 5 is 40. And then if I take 40 off of 41, there's 1 left. So a negative 8 wholes and 1 fifth-sized piece remaining. So that means over 8 cakes got eaten. If I had to cut into the 9th one, then I get to charge them for the whole 9th, the whole 9th cake. Ha ha! I'm just excited to have found a meaning for the negative fraction. All right, and then 124 ninths. Yuck. And it's bigger than 90, so there's at least 10 9s in there. And that is actually one of the ways to handle this kind of question. Like, you can do it, and that's what most people do with these mixed, with the improper to get it to a mixed, is they'll actually start with the old school division. And you can go from there. And this isn't wrong. It does work. I just find the way this particular algorithm is taught is god awful. And I learned a new one when I was teaching that class last spring. So when we're asking how many times does 9 go into 12, what we're actually asking is how many 9s can I get out of 124 or 120 or just 100? Well, I know I could get like 10 9s. I could get 90 out of that. So I would put the 10 up here and then subtract off 90 from the whole number. And that's going to still keep the 4, but that's going to leave me 34 of them. And now 34, well, I know 18 is smaller than that, so then I might say, okay, I'm going to take 2 more 9s. And what you do is you just stack these numbers up on top, and then we'll count them all together at the end. So minus 18. And that would, this becomes a 2, this is a 14 now, so 6. 16, so I can get 1 more 9. And that leaves me with 7 left over. So that is 10 plus 2 plus 1, 13 9s with 7 remaining. So this is the same as 13 whole things with 7 ninths of 1 more. So it's in between 13 wholes and 14 wholes, or the number 13 and 14 on the number line. So that was a whole lot of information at once. Again, the calculator will actually do this for you. What I want you guys to really focus on here is the ideas behind what we're doing. Like different ways to think about what a fraction represents, because that is more useful than just the initial gut feeling of, oh God, I hated fractions, I don't want to. So you're not going to crunch the numbers by hand. You got a calculator. Even your basic calculator on the phone, a lot of them are Google, will do this. Like, it'll do fraction math for you. It goes to Wolfram Alpha, and Wolfram Alpha will give you the answer of anything from pre-algebra to calculus. Literally, it'll calculate anything. Which is why I would respectfully ask that you don't use the internet when you take tests. Singular, because we only have one. Or your quizzes. You've got your open notes. I would rather you guys put forward your work and made an honest mistake than mistyped something in Google and just copied the thing because you couldn't think about it. That's what we want you to get out of this, is critical thinking. Does your answer make sense? I legit will give you most of the credit if you show me a bunch of work and then at the end you go, that answer makes no sense. So you recognize you made a mistake. You may not have time to find the mistake, but you recognize one was there. That is worth more to me than doing the problem, picture perfect. Ironically, it actually is worth more to me that you can read and recognize your mistake rather than doing it perfect, because the mistake is how you learn. I know we don't like making mistakes, but if you make them in a controlled environment where the risks are low, you don't make them when the risks are higher. Like when we ride a bike, we have training wheels, so we learn how to balance where the risks are low, where if the bike topples, the training wheel catches it, and then eventually you can take the training wheels off and you ride your bike like normal. That's what your mistakes in math are. They're your training wheels. Make them now so I can catch you and say, oh, there was your mistake. There was your mistake. I know, I come up with lots of weird life analogies. All right, my lovely students, I will see you in class. Enjoy the videos. I will be posting more.